In order to write the balanced chemical equation for the combustion of propane, we first need to complete the unbalanced equation by writing the other reactant and the products. The other reactant is oxygen gas. Be careful here because this is one of our diatomics and needs to be written as O2 and not just O. The products for complete combustion will always be CO2 gas and H2O gas. We want to keep track of how many of each element we have below the chemical equation. So to begin with, we have 3 carbons, 8 hydrogens, 2 oxygens, and these are all on the reactant side. Moving to the product side, we have 1 carbon, 2 oxygens, 2 hydrogens, and 1 oxygen. Considering our guidelines for balancing chemical equations, we want to balance those elements first that appear in only one location on each side of the arrow. And we see this holds true for carbon and hydrogen. Carbon only appears in propane on the reactant side, as does hydrogen. On the product side, carbon only appears in CO2 and hydrogen only appears in water. Oxygen, however, appears in 2 locations on the product side, in CO2 and in water. Furthermore, oxygen exists as a free element on the reactant side, so we will balance oxygen last. This order helps to minimize some of the back and forth that can happen with balancing equations. So we'll balance our carbons first. We have 3 carbons on the reactant side and only 1 carbon on the product side. So in order to make these balance, we'll need to put a 3 in front of the CO2. When we do that, it changes the numbers of both elements, and carbon changes to 3 and oxygen changes to 6. It appears then that our carbons are balanced, so we'll check those off. Next, we'll balance the hydrogens. We have 8 hydrogens on the reactant side and 2 hydrogens on the product side. So we'll need to put a 4 out in front of water, and that changes our hydrogen to 8 and oxygen to 4. So it appears that our hydrogens are balanced. Next, we'll balance the oxygens. But notice on the product side that our oxygens are in 2 places, so we have to add them together. So we have 6 oxygens coming from CO2, 4 oxygens coming from water, so we end up with a total of 10 oxygens on the product side. In order to balance the oxygens, we need a 5 out in front of O2. That changes our oxygens to 10, and our oxygens are balanced. So the final balanced equation is C3H8 plus 5O2 goes to 3CO2 plus 4H2O.